Hey everyone, welcome back. So today, we're gonna finish up adding the model, and then if there's time, do some other stuff. The big things, I've made a number of changes last night. I didn't stream it for well, just because it was kind of late, but I think basically I just kept updating that config that I made for the unit test. So yeah, if we go to Circle CI, essentially, I did throw in, as I said, I was going to do that unit test. So it looks like this is actually returning a tensor of a different dimension than you'd think. So all we have to do, so we have to fix that, but we also have to fix like kind of the loop for the other code. So that's for the training loop to be able to take the Gaussian loss function, which I said was kind of difficult. So so that's the main thing. So yeah, this I discovered last night too is probably just due to the dimension not being exactly correct. I think that what happened was that it's returning an extra dimension, whereas we only need it to. The return values of stuff should actually be, in general, two-dimensional, and this wasn't. So I'll show you that in a sec. So as I said, again, this is my dummy notebook where I'm just working to test different things out before committing to the main repo. Um, so yeah, um, the idea is to fix that first, and then we'd be able to actually run this model with any loss function, not just the Gaussian loss function they used in this paper, but a more standard loss function too if we wanted to. Um, so, that's the main stuff we'll be doing today. So, uh, and then doing the stuff with the Gaussian loss function. So yeah, the shape is this. So basically, I think if we just unsqueeze, I don't know. It's possible if we squeeze one off, it will get rid of one everywhere. I forgot exactly how that works. Oh yeah. So then we do dot shape. That's odd. Or the other thing we could do, as I've sometimes used, is view. So you could do like view. Actually, let me look that up. Um, Here, I'm just gonna assign this something. Usually I would just do unsqueeze. So I might do that here. Or no, squeeze rather. Squeeze. Yeah, I think. What was that shape? Okay, yeah, I think then that will be the right shape. So in this case, I'm just gonna have this return this. Um, the one thing I was thinking. Oh wait, this is another model. Was that it's possible that I wonder, did I comment in my original data loader the shape of stuff? And this is good where it's good to have shapes. So, um, so yeah, so basically, yeah, the for method. We'll do that thing where we write out our args again. X tensor of dimension So yeah, I'm just writing out kind of so this is clear what this is doing. So this would be batch size, and then the output sequence length. Oh wait, now I'm remembering something. Yeah, I was just remembering too that this. Oh wait, yeah, that's actually kind of weird. Yeah, let me go back. Cause yeah, this is returning 1 and 10, but that's like the output sequence. So it's like. So wait, I guess sigma. I thought sigma though was doing it to 1 though. It's kind of confusing. Because, yeah, in theory, I'd think this would only be forecasting 1 time step ahead. And right now it appears to be forecasting essentially, and it seems to be forecasting whatever the number of the number of steps we put in ahead, or whatever the forecast history seems to also be the thing they're forecasting. I'm just gonna try that for mu too. I'm gonna see what it is. Yeah, w.shape. Yeah, I think it's exactly the same. Yeah, so that's kind of weird that that's like actually. Okay, so this is just mapping apparently the embedding dimension back to this thing. So actually in this case I think this would have to match like in here. Let me go see. Like if we go look at our config, I mean then the forecast, if like say we're doing forecast history of 5, the forecast length would also have to be 5 in this case obviously. So actually that if that's the case then that should fix it, but I don't really like that because that doesn't give us a lot of control over the forecast length. So that's something we need to look at, and probably what we'll do is we'll add another linear layer. I guess so in the paper then they were actually forecasting. It appears that at least that with that, they're actually forecast some distribution at the end, which is different. I don't know if they did a different like inference mode for it or something, but I don't think they actually yeah, forecasted the stuff. So oh, I think that's right. So yeah, let's go back. I forget, did I formally link this to the issue? I think I did. Oh, now it's saying I have 2 merge conflicts if I want to merge. Yeah, so, so anyways, we'll let that run and see what that says. But yeah, I think we probably want to add kind of a variable layer to whatever that is anyways, because yeah, it appears they're just forecasting based on this model, and now it appears that they're just kind of taking whatever this is, or unless this is tunable in the this transformer part, which I don't know. I mean, actually, too, you could potentially do that in the query and value vectors, right? Because like if you do your query vectors of just a length of 1, then it would be Yeah, it would be that. Wait, maybe is that actually what sublin is? I'm still remembering a bit. I know I looked over sublin a lot yesterday, but no, I think I specified sublin in here, and so that should be 1 then. Or did I? Wait, what am I putting to sublin then? Yeah, sublin is then defaulted to 1, not the sequence length. Okay. God, it smells like someone's smoking outside. No, it's coming in. Oops, I shouldn't crash. Okay, so yeah, I don't think this thing's doing it now. In any case, so, yeah, we could definitely try that, I think. So yeah, case 1, tensor, dimension, batch size. We're gonna, like, put an additional param in, probably of forecast length, is my guess right now, is the way to deal with this. Yeah, we can make it required too. It's not a big deal. God, what the fuck? People are. Okay, so yeah, and then of course we have to update like our config file. And then basically all we're gonna do is add like a couple final layers for that, so. Self dot. Oh wait, yeah. We could call it something like that. So it's just gonna be like nn dot linear, and we're gonna take basically just what the forecast history was and map it to the forecast length. Yeah. Though I am gonna see what exactly this unit test does, because yeah, I mean, but it appears that, yeah, actually I might try looking at the actual paper too. Oh wait, this failed again. Must match of size must match. It's the same error. Thought that would have fixed it. I'm gonna print the shape of sigma just for debugging here. Or wait, I already know it actually from what happens there. The thing I don't know. So it looks like it's saying, wait, back here that it's comparing. So at dimension 1, and one of these tensors is 5 and the other is 4. Which, if I look at my config, well, I mean, 4 is the batch size. So it's possible. yeah, that it's now trying to compare batch size to the other thing. But yeah, that's weird. I mean, usually what we'd see is that batch size should stay the same unless this thing got like rotated somehow. Um, Labels equals target. Um, so we're just taking the raw output of the model there. Well, I guess I will copy this again just to see what the my actual. 'Cause there might be some discrepancies between that, so I'm just gonna push that down. Oh yeah, it's because we added that new parameter in forecast length right after QN. Um, right after QN. Oh yeah, we made that default too, so we'll just say that's 1 for now. And then we'll just try to get the shape of this. Because now we're not returning both. So yeah, it is just the same dimensional tensor. So yeah, so in theory, I'm just thinking this should then be, what is it? I'm gonna print actually, probably, some crap, maybe even in the training loop. Because actually, I'll go back, get the exact line. It's when it's running the criterion that it's doing this. It's encountering the error, I think. Yeah, so yeah, it's that. But the data loader should be, yeah, I think if we squeeze, yeah, I don't know why it would be 5 to 4 though, because actually if you run a criterion onto like things that aren't the same dimension, it should give a different error. But I guess I will try squeezing, because so yeah, just squeezed 2. Just try that squeeze. Oh wait, I'm gonna go look at my data loader again. Flood forecasts. Something. So yeah, I mean, I don't know exactly why that's doing that. Actually, yeah, probably it's easiest just to throw in the train loop and do something there. So yeah, I'll just do actually I should probably really write above labels, a comment right above labels when we get this in a second of what the shape is would be really helpful. Because I of course probably should know what it is, but I've forgotten, so of course I am going to delete this stuff in a bit. So yeah, even though we add this kind of layer here, right now we didn't add it to the actual thing, so it doesn't change really anything. We'll add it like next time, probably, but I just want to see, because in theory, if you are giving it the same length, it should actually be working. So I think there's actually something else going on here. Yeah, add add print, and what did we add? Add layer temp or something like that. Oh, it's kind of a weird commit message, but so we'll just wait and see what that does. It should be interesting. Of course, it's going to generate like a lot of junk stuff in all of our other unit tests. That's why we'll just do this temporarily and then remove print. So that's running. So yeah, while that's running, we could actually look at adding this stuff for the other layer. So, okay. What I'm gonna do now is I'm going to, well, I need to find my original thing. There's config. I'm gonna close some of this stuff that doesn't matter anymore. So, okay, yeah, so we can implement the actual, we can at least begin to implement the actual layer now if we want to. So, yeah, actually, this would probably be better as an optional parameter, in my opinion. Yeah. This is gonna screw up my format, because yeah, I was just thinking, if we do want to use their default settings, then we don't want to have that layer, and then we can just like do some crap like set it to like none or something, and then that would be good. So, and of course that's gonna complain. So we just do like if forecast length, and then we initialize the layer, and then yeah, and then we'll, to make it easier there, we just do like none. And then yeah, then we would here just do I don't know if we'd want to do it before or after soft plus. We could see about, for soft plus, I think just make sure the value is positive. I think so. So yeah, it just looked like it constrains it to always be positive, which could be good, could not be good, I guess. Well, I mean, technically, I guess if you have like some forecasting problem where you got negative values, I mean, obviously, when they were originally doing this, I think they were using this for the overall distribution. And so they wanted to have it be part of it be positive. which is, I think, why they ran it for soft plus there. So yeah, I don't know. We could maybe use soft plus, maybe not. But yeah, I don't know if it's like actually going to. But yeah, the only thing would be is like if I don't know, maybe some sensor data you could have like negative values or something. Yeah, I might not use it there, or I might do that layer. I don't know. I might not use it then. We'll see. So that failed already. Oh, did I not print shape? So yeah, it's saying, yeah, basically that end dimension is incorrect, and then but I still don't know how it gets to that 4.5 saying using a target side torch 4.5 that is different from input size 4.5.1. Yeah, so high torch removed in 1. Yeah, that, or we could do reshape too. I don't remember which is faster, but we just do something like maybe reshape. -1. Oh, only one dimension can be inferred. Oh yeah, that makes sense. You just, yeah, you could reshape to like, yeah. Yeah, that's basically the same. Yeah, so or it's probably easier actually to get the batch size here. X.shape.0. Oh yeah, and we will change out the shape because so this thing like worked okay even when the dimensions were different initially, but then it hit some kind of error at the end and stuff or something. So I don't know what that was, but we'll keep in the print stuff. Oh, print labels.shape. So I should have shown the label shapes. Yeah, I'm still not sure how 5 and 4 became like different dimensions. Actually, maybe there's more detailed debugging here on weights and biases. Because even though those things were unequal, I still don't see how like suddenly. Because I'm pretty sure this was just initially a warning. And then the actual traceback happened because 5 and 4 didn't match. But that they should match because these are still the same first two dimensions. Though. So I don't know. I don't know what's going on with that. But let's go do that. Oh, it could be in validation loop too. Yeah, maybe in the validation loop or something. It's like trying to compute validation. Oh yeah, that would probably be my guess actually. So yeah, actually removing that should work because then it shouldn't like kerplunk in like validation. So yeah, this actually ran okay here. I'm guessing it just like it was in validation because there's a slightly different way of doing it in validation loop. Or it might have even gone past validation and been more in like test loop, and then that would have been like definitely different. Because yeah, if it was using decoding or something, it would have like screwed that up. We won't commit that right now because it's just removing the print. So yeah, I think that should work now. For that at least. So yeah, what can we do? Yeah, we can finish adding that stuff then. The forecast length stuff. You also finish adding case 2. Return sigma and mu val tuple. So yeah, either returns that or 2. Of essentially, yeah. Then each of those is essentially, if we're doing sigma and mu, it's that forecast history 1. So this is what essentially the return type would look like for sigma and mu. So that's the, yeah, so that will run initialize weights. So yeah, we can add the actual type hint too so that people can see. This is obviously a torch.tensor. This is obviously, well, not obviously, is an integer. It's what it wants spacing now. Yeah. Okay. So this is a torch.tensor. This is an integer. Well, it's either an integer or it's none, I guess, is a better way of putting it. Oh wait, isn't there that typing thing that's like optional? I've actually never used the optional type stuff before. Missing white space after. What? Oh, it's saying there are multiple spaces? Oh, this is 2 instead of 1. Okay. Yeah, I think there's like an optional thing in typing actually, which is probably better to use. Okay, I don't know exactly that is. I won't add that now. Or wait, I guess that's not optional though, because that's actually, anyways, we do the optional here, maybe like this, optional or something, I guess, but I don't know. I'll have to look at that in more detail. Okay, trainer's still running. It probably hasn't loaded the main stuff yet, but the computer's really overheating. See what happens. Yeah, it's still installing dependencies and stuff. I won't actually commit this now, because then it will re-trigger the test. I'm just getting the commit message ready. So, so that's running. So what can we do? Crap. It's a big truck. So yeah, what I often do when I'm waiting on stuff is, well, I'll either add more to like documentation or the code or whatever. So that's kind of one of the things I do. Oh, if you haven't seen it, like our official like contributing guidelines, probably most people read these first, are actually like here. So, if you are contributing, you can just read these over. So this is actually a good example of like a complicated model, with complicating factors. Though it's not like the most, but it would just be like, because it has the loss function. So like if you're going to like add a model like this and like with the custom loss function, it would be best to ping me first, because it can definitely complicate things. Other models that are much simpler like are pretty easy to just throw over from PyTorch and require very few of these adjustments, but let's go. Where is that stuff? I think I thought I had it somewhere. Okay, so I failed for some. What, did it really fail again for the exact same crap? That's not possible. Where a minimum of 1 is required. Found an array with something. So what are all these warning messages? To copy it, okay, well that wasn't my code, though maybe it would be good to look at if it's doing all those warnings. So first, found an array with 0 features and stuff. Wait, how did it get to like 341 0? Oh, that might be because, yeah, that might be because like initially we were just doing it the length of that, which is creating problems in some of the other like evaluation code. So yeah, that's actually a separate bug, probably related to problems with some of the like stuff in Evaluator. So, I don't think that would happen if we gave it, say, like a nice, like, divisible number, like 10. Or something. Oh yeah, it's probably because we're also doing that, like, thing where we're not using, like, the standard decoder or something. Or are we? Oh, we are doing simple decode. It's weird. Okay, I'm gonna take a break for a sec and then come back. It's fucking hot. Okay, so we're back again. Okay, yeah. So as I was saying, that those problems were like with Evaluator somewhere, and they were, and so yeah, there's actually some problem which, yeah, isn't great because, yeah, it's kind of weird. Found array with 0 features. So what it's saying is that there was an array, essentially with a dimension of 0, which means it was just kind of null. And it happened somewhere in Evaluator, which is actually code I really don't want to go into because it's ridiculously complex, and yeah, and yeah, just in general, it's just ridiculously complex code. But so anyways, we have to look into it. So now we're here in the evaluator code. So with evaluator code, the main things were that it's hitting the error here when it tries to unscale these predictions, and the problem is that apparently this array is null essentially, and is essentially, yeah, some way null. It's apparently, I think it's actually not even the right shape too. It's like instead of being, let's look, instead of being, it should be free 36. So it looks like this thing ran one extra time. And so instead of being free 36, it's actually free 41. Or wait. No, that's right, I think, because yeah, we'd have the forecast history in there too. So that's actually right, because like when we go to plot on weights and biases, and generally have both the forecast history and the forecast if you look at like our charts there. So yeah, that's probably actually correct. So I'll show that real quick if people want to see. Like, yeah, just in general, if you've seen any of our charts before, you know that basically we start with like that. Well, I don't see anything here, but but yeah, if you've seen our things before, you know that like it basically starts with the predictions, and then goes like to the actual forecast. So that's kind of the main issue. So what we need to do is well, so the question is, why the heck is this 0, and why is this shape 0? Which we don't, which will involve us diving into the weeds. I mean, usually though, I mean, that thing, the code there is very complex in Evaluator, but I'm almost positive the Evaluator coder is right. So my thing is it might be something that was probably done wrong in the configuration file, which is causing the problem, would be my guess. So I'm gonna look over the config file first. But yeah, actually the config file, from what I've seen here, looks in general correct. Unless, we didn't actually use that thing yet, right? Yeah. So yeah, it's really weird that would come out to that, particularly like you could see where there might be some way it would be the wrong value, but just to have like a completely null thing. So I guess one of the first things to do is like print the. So it does like untransforming here. So basically, yeah. So basically, this n tensor. So we can just look at like print n tensor dot shape and see if the initial tensor is wrong. So yeah, this actually isn't bad. We're getting rid of some debugging code just to add others and our changes. So we'll just do that and then like go from there, I guess. Actually, I might want to print this. Yeah, I'll print this right below like here or something. And then I'll also, because yeah, it really just depends on what n tensor is. Then I'll also just print n tensor list. So yeah, we can see like if the problem's with the initial end tensor. My guess is it is because I mean I don't see why the Evaluator code would be fucking it up, um, but it's possible it's with the something small there. But I want to see like if the shape is 0 even then or something, or if it's like a later conversion. Okay, so yeah, we'll go ahead and push that and just let that run. So, okay, so that's the main stuff. So we'll probably just wait around for that to run. Wait around for that to run. The other thing that I was looking at, was oh yeah, adding more stuff on is we can actually begin creating more of a supported models page. Now we already do have a page on transformer based models, though I haven't added much details to it. But yeah, we could add the transformer bottlenecks thing. So yeah, this is kind of the more extensive documentation. We do have the read the docs and the type hints, but for actual details on the paper and like some of the changes we made to models, we basically will document most here. So like we have actually a bunch of different transformer models. I'll just say this was at like NeurIPS 2019. And stuff. But yeah, the idea is just to like provide like more thorough documentation and also like how our implementation maybe changes from others. So yeah, I'll just start documenting additions here. An option, another final layer to the model that should probably be bold. Like we should probably do like, oh no, I don't want that though. So like another good thing to do sometimes when you're waiting for your test to run is also to run like experiments with your other models in the background so that you can make sure like some model experiments are running. But yeah, I won't do that right now. But for now, yeah, we add another final layer to enable variable length forecasts. We also enabled the model to work with standard loss functions. We did this just by so yeah, that's just basic documentation. It doesn't have to be that extensive while you're going, but over time this will become like just that stuff. So here's an example of one I've documented a bit more, and then as you get results too with forecasting with the model, I often will create tables and then link them back to the weights and biases reports, and this just creates like a really clean record of like the different models, how you modified them, and kind of what their records look like for particular problems, which I find useful. So let's see what's going on with the test. Yeah, I'm really, this isn't good for my, well, it's just like a real pain because like I remember evaluator stuff has been ridiculously hard to debug in the past, so I really don't want it to be like go into it. Yeah, I wonder if like, I know that was their original implementation, but if there's a better way of doing that. I'd actually just comment on that, like, somewhere. Maybe actually in the issue, I'll just make a note that, like, okay, looks like it failed again, so we should be able to see this. Or that's not an error, I guess that's a warning. But yeah, my perspective on a lot of this is to document stuff as thoroughly as possible, either in the issues or the official documentation page, so that like you like so like there's kind of a running public record of all your design decisions and like why you did them, and you don't just forget about stuff later, or even if you have to push something off because you're like time constrained, you can come back to it and say, oh, I never did fix that copy construct tensor thing. I should probably do that now or something. So I'm just gonna quickly try to remember the line for that. It's like when it initializes. It's like it actually does that. Like I think it's in here where it like uses that like torch.tensor or something. Yeah, it's where it does it here. 260. Just quickly say. I'll just quickly update that. I should probably note the lines here. Line 260. I can fix formatting later. I want to get back to the actual thing. So no, that's the old one. It's the old one. So we can see what's going on. Hopefully we found array. Okay, so actually here the tensor shape looks correct, so to speak, because it's a 336 dimensions. There's no 0 here, so at least at this point it looks like the tensor hasn't been corrupted yet. Why it's suddenly being corrupted now in a second, I don't know, because this code I think is fairly, where's the code? It's fairly straightforward. But if here's that my guess is that, let me see, and why this is now occurring here for this model but none of the others. Oh, it might be because we're doing like some of this like reshape here though, actually, because like we do like this and then we reshape -1 1, but it's only one dimensional. Actually we can play around with that in the notebook, because like that's probably why. I'm guessing that some of the other models actually probably returned a dimension of probably 336 1 for whatever reason, and this is only returning 336. That's just my guess though. So but that's my but we'll see what this looks like. Tensor dot to numpy. Is it just? I think it's just numpy. Let's see what this does. Oh, so that's actually okay. Let's say we can actually copy some of this stuff and just quickly and see. Yeah, so and the list looked okay too, actually. Wait, was that the same one? And then it's in line 118. or 103 and then 118 in inverse scale. 118. Test data dot inverse scale test predictions. So that is this line. df predictions dot numpy. Okay, df predictions. In tensor oh wait, df predictions is actually something different than in tensor. I just realized that. So it's like when it's trying to inverse scale this df predictions. I forget how I did this, but I can go for here. Inverse scale. Where did I inverse scale shit? Test data inverse scale. Okay, so apparently it's not the n tensor that's the problem. It's df predictions and stuff. So yeah, it looks like that's the last one. Return df prediction samples. My guess though is that like it probably is something to do with just a slightly different dimension that's like corrupting it somehow. So it's returning apparently this pd.data frame, which is what the prediction samples is. This is a case where having that type hint's really helping. So this is apparently this prediction samples when it's returned here. I really hate, this is one of the reasons I hate going through this code because it's so freaking complicated. But unfortunately, there's not much way to make it not as complicated. But so prediction samples. So yeah, it's apparently this df predictions that's kind of like the problem. So can we print actually? So I'm just gonna change this. Because yeah, there doesn't look to be anything wrong with the prediction tensor. It's this data frame that looks like it has some of the issue. And I don't know why it's doing it for this model. Yeah, crap, I need to plug in my computer too. Oh, I need to plug in. Yeah, I mean, it seems really weird though. This is returning the correct tensors and stuff that, like, this would be given this problem of, like, with the predictions. Or another way. I mean, I guess I could look in the function too. So, I mean, this is from the infer on torch model. DF prediction samples. Okay, we'll just do this. Okay, so quickly wait. Now we'll have to wait for that again. Yeah, it's just really weird that that model suddenly isn't working with that. I still wonder if it's just some stupid problem with the config file too. Because if it's returning everything in the proper dims thanks to us reshaping it. Oh wait, it might not be, right? Because it's possible it could have screwed up, like, batch size. Is it? Could have screwed up. Okay, so that's batch size, forecast history. Okay, wait, how was I doing this again? This might not have been the best way of doing it, this reshape. So yeah, it just infers this dimension. And it just kind of infers batch size, I guess. I'm gonna play with this for a sec, because it might be that it's that end thing that's like, what did I call? I called, like, reshape a couple times. So if, like, this is actually, I don't know, something like 110, 420. Oh. Yeah, that makes sense. 410. Yeah, so forecast. It's a simple decode. Sigma if so yeah, that should all be that. And n tensor is right too, so I don't get why, particularly if n tensor is right, it's not doing evaluation right. Wait, I put that in right. Yeah, if n tensor Wait, what am I doing for prediction samples? Am I doing that here? Yeah, but this was copied from the other config though. Wait, prediction samples equals this, but this is only if it's not none. But I haven't had that problem before on any of that. Wait. Or is this predictions? Predictions is the last one. Yeah, I haven't had that problem ever before though. With any of the other models, so I don't know why it would suddenly come up now. Equals infer on torch model. So that's where it's coming from. It's coming from infer on torch model. And then it is returning prediction samples. Wait, does standard scalar work on that though? Because it could also be because I switched to standard scalar. Yeah, that's possible. Okay, standard scalar. From sklearn. Okay, just let's try something. No, so that's the exact same error between the two. So yeah, why the heck does that have 0 and stuff? It doesn't make sense to me. So predictions clearly isn't 0. I'm guessing those are the prediction samples. Or wait. That was in the last commit, right? Untransforming data. Wait, am I still... What was I printing there? U predictions. I did still print the n-tensor list there. I don't care about n-tensor though anymore, because it's not that's the problem. Okay, so it's actually... So actually, yeah, this part's running fine. So n-tensor's not running fine. It's just the DF predictions that's not running fine. Which is the additional predictions. So, because yeah, it's like, I think on line 100 or something that it fails. Yeah, 102. DF predictions.numpy. Okay, but so yeah, how are all those other tests passing then? Okay, yeah, of course, yeah, I didn't change Evaluator at all. Yeah, so that should be fine. So it's just that this is like doing something, so it's just the DF prediction stuff. So yeah, so it's just okay, so and the weird thing is I don't see how this would work ever anyways if prediction samples is none, because then essentially if number prediction samples is not none, we still have this essentially this data frame that just has an index. and no actual columns and stuff. So I don't see how that would work in the first place anyways. Though apparently for somehow it has been working, so. Yeah, that's the weird thing though, because like this gets returned last, and that's what that becomes. So then like how when any other JSON config has that, does that actually work? Because none of the other JSON test configs I think have that anyways. Like, oh wait, this has number of prediction samples. But the one I got it from definitely doesn't, so. Yeah, like this is running, so I don't get like. I don't get how that scaling thing would ever work and stuff. Because I'm pretty sure that would always be. Yeah, because I'm pretty sure that would then always be. Wait, test data dot inverse scale. Yeah, because that's just the straight DF predictions. Basically, because yeah, when it gets it, it just takes the index, right? Or is that what happens when you create? I just need to create a pandas data frame quickly. I don't even have any CSV. Or do I have a CSV somewhere? I don't think I have a CSV up here. I could just throw up some random CSV or something. Yeah, I'll just throw up this CSV. Because that seems really weird. I don't see how that works altogether. I think it was Michael or someone who added that code, and I honestly just don't see how it works. It's very confusing to me. So yeah, if we just read, because I don't think that should work. It's like, so yeah, if I do like df.head, and then I create like a new df just based on this df, does it just copy everything from this df? I don't think it does actually. So like, because like particularly when you just say index, I don't see how that would ever create the. But yeah, we can look at it. So. Maybe it does, I don't know. No, it's literally just the index. And then if we did something like numpy on this, and then did numpy, or what do we call on this? I don't even know what we call on this. Then essentially according to that, if there isn't the prediction sample stuff, that's essentially then returned like none or some shit, right? That's just like directly data dot. We just almost directly call inverse scale on it. Can we go look at inverse scale? Is instance. Okay, inverse scale is instance torch.tensor, or is instance. Oh, someone actually added to this a while ago. Wasn't me. Alright, that's not how we did it originally. Okay, I'm gonna look at this. This is something I probably should have checked more closely when people were merging this stuff. Because now, yeah, I have no idea how this is actually working. I find these long lines confusing too. It's like, because yeah, I never remember the work. I definitely did not write that function, and it's changed a lot since I used it. Check df2. Oh wait, oh yeah. We'll just call this result data. Okay, but yeah, then we get the zeros thing. So I don't know how that's ever working though, because it's like, because like we're literally getting that numpy shit of like dimension 0, so it's just not, it's not clear to me at all how that's working. It's not clear to me how it's working for the other models. Yeah, I mean, so like, how's it working for all the other unit tests we're running, for instance? Is it like, because that just doesn't make sense to me, you know? It's like, how are like these tests running, for instance? Like, how's LSTM running when it's then not generating prediction samples? So yeah, I don't know how that's working then if that's not generating the prediction samples. So I guess we could look at the if statement again. But like okay. So yeah, or no columns if number prediction samples is none. So how is that working then where like that's passing and then wait, did I get that whole thing? Now I'm getting really confused again. Data sets. Evaluator. Where the heck did my other stuff go? No, what? No, don't save that. PyTorch training. Transformer bottleneck. Okay. So yeah, I still don't know. I still have no idea how that's working for those other cases. In that case, because this should not be working then. If test data dot scale, yeah, so we are scaling. Um, so it calls inverse scale. Um, this is calling a scalar. Is required, so I don't know how that's actually working at all. Because yeah, according to this, like it shouldn't be working for the other models. It's like though it is an inverse transform. Maybe I don't know. S dot fit transform. Do S dot fit transform. Like I don't know. Like DF or something. Or DF maybe just like some random columns. temp f, for instance. I don't know, come on, stupid thing. I don't care about that shit. Just fucking... who wrote that anyways? I'm gonna look at my git blame. So, okay, so s dot inverse transform. So I don't know, it is possible maybe inverse transform works a bit differently. I don't know. But it might, I don't know, I guess. My phone. Could send me an email. Okay, yeah, I don't know. Someone was just calling. Yeah, then it basically makes almost no sense how that's working for those other things. I'm gonna go quickly look at something like who changed that initially. Not that it's bad. I mean, it's actually kind of interesting what they do with the function. Or maybe they know. PyTorch letters. So yeah. So yeah, that was Michael a while ago. I don't know how that actually works now. It's just like it's baffling to me how that runs with the other stuff, but for some reason it doesn't run for this. I mean, maybe I don't know. Maybe if we swap it to standard scalar, maybe it will in theory run. Maybe it's just robust scalar that's not running. So I don't know. We could try that. Like, it's worth a try. I mean, I don't know if there in theory shouldn't be any difference, but maybe standard scalar just takes more of that. But I don't know. It's amusing because everything about that says it shouldn't work at all, but yet for some reason our other unit tests are working with it. So, what actually should probably be done instead? I mean, if we look at it, where it does, this long is instance stuff. It should like check that like. It should probably check that. There should probably be a check that the data frame actually has columns or something. And then if it has no columns, we just like, and that should probably be done in Evaluator. So like probably before we even do this, like if df predictions, how do you check the number of columns? I forget. Number of columns. Pandas. Oh yeah, yeah. So yeah, we could just do like len df dot columns. So I mean, it is really interesting that that actually works at all. Len df dot predictions is greater than 1 or something. No, greater than 0 actually, I think. Then we do this. Um, I think that's basically the fix, but yeah, let's see if this actually works with this, cause oh shit, I think Circle CI just hit partial outage, so we might be stuck for a while. So, Jehood. There we go. So, yeah, so that's kind of weird. So yeah, so additions. So yeah, while that runs, we can fill in some details here, a bit more. I'm just getting the paper URL again. So yeah, and as I said, the goal is just to make this some like clean documentation. We added another final layer to enable variable length forecast, and we should probably do these as bullet points, I think. Let's see that. We also enabled the model to work with standard loss functions, MSE, RMSE, etc. Kind of want to do like what I did with the other one though, and do like, let's see, it's running. It'd be weird if standard scalar is actually like different, somehow different from robust scalar, that it can overcome some weird errors. But then I guess robust scalar actually isn't that robust, right? So yeah. Okay, so yeah, I want to create like kind of a table like thing like I did here. Yeah, I forget how I did that. How did I do that? Oh yeah, I just inserted this, I think. Yeah. So yeah, I just then put like stuff like original paper. What else did I put? Oh yeah, flow forecast implementation, and then I just linked to it hasn't been merged yet, so I won't link. Oh yeah, and then I do like a notebook showing what to do, and then yeah, etc. etc. Oh yeah, and I do like a summary. Yeah, I can just do that, and then like I don't know what I'll use this first for. Probably river and stream flow forecasting. But yeah, I'll obviously add those links when I actually run it. Succinct summary. So how would I describe this model? A variation of it's basically, yeah, it's like a variation of the transformer that replaces standard self-attention. What was it? It was quick. They did value and something other vector. It was the query. It's the key and value vectors, I think, that they actually changed, right? yeah, so oh yeah, so it's the query and key vectors. Yeah, it's the query standard self attention with conv convolutions for the query and value vectors. Performed well. Oh yeah, then the other thing I think that they did kind of that was interesting was the learned learned positional learned positional embeddings. Anything else that they did? I can't remember actually. Yeah, I think those are the major ones. And then yeah, it performed well on large temporal data sets. Okay, so that's kind of like our succinct summary. Um, so yeah, okay, what's going on here? Oh, trainer test is still running, so I guess that's somewhat of a good sign. Oh, so it did. So for some reason, standard scalar apparently can take an array with, you know, dimension 0 and stuff, which is really weird. I think we should probably add that like fix anyways, so that like robust scalar and those other scalars would work. But yeah, this seems to now actually be running, so. Okay. So yeah, I'm gonna let this run and see what happens with the other training tests. I think yeah, we should probably commit this anyways, so that things like robust scalar would work, and then probably actually change that config file back to robust scalar. Um, but yeah, that's kind of good. We've made good progress today, so I think. Um, But yeah, that's why the other unit test didn't pick it up, obviously. So, okay. So yeah, we'll just wait for that. So the other part, the part two that I'll probably discuss either tonight or or maybe tomorrow. Um, because yeah, I have to get ready for some other stuff right now. Is then going back to the PyTorch training loop. Right now, we just kind of made the model work with our loss functions, but we actually haven't incorporated their Gaussian loss in that they actually use to train it. So, oh yeah, we also haven't actually finished actually implementing this forecast length layer. Though this is pretty trivial, actually. We could do that right now. So so we could just do like if forecast f self dot forecast length layer, then we do sigma is going to equal self dot forecast length layer, um, and yeah, just sigma. So though I don't know if we yeah I guess we could leave the soft plus there maybe, I don't know. I don't know if we should or yeah, actually let's move soft plus here, because I think soft plus is really actually associated with doing this and stuff. So yeah, we can move that there. So that's basically finished us getting the model able to work with our existing loss functions, but as I said, it doesn't add the new loss function to the model. So yeah, I'm actually have to give a call back to those people. So to see what's going on. But yeah, so I think this was good live stream. Found a bug. Yeah, we should probably change actually this back to robust scalar now, and then do like one last commit with this stuff. So yeah, that was an interesting bug. Interesting how standard will work with at least the inverse transform, but robust won't. I don't know if that's something. What's with sklearn in that? But yeah, that was good. So yeah, we'll recommit this. Though actually since this is now being supplied, we'd actually have to change some more of these parameters, because now that we have it here, we'd have to change that. But actually, we could keep this here for now and just not have it use that layer. I think that's probably a nice, easy solution. So okay, and so yeah, that actually entirely passed. So yeah, we're getting closer. It really is just now fixing that last little part with the loss function, and yeah, just doing that. Okay, and yeah, getting that Gaussian loss to work, because that as I said is more tricky, because it's actually initialized each time by the output of the model, and then you pass the actual results back into it. So it's a very odd loss function, actually. At least the way it's implemented. I don't know if it's used in a lot of other people use it, but yeah. Let me actually look at that. If it's doesn't look like it's too long, I might just try to push through and finish it. Where's my loss functions? Oh yeah, they're in custom op, so here it is. So basically, yeah, we have to initialize it with the mu and sigma that's outputted, and then we have to actually send the x, which is the result of the model. So probably just a high-level overview of how to do this. I don't think it actually will be horribly complicated, but it will require modifying our core training loop, which is sometimes a pain in the ass. Oh yeah, it might require some other stuff too, because like it might require actually modifying both training loop and validation loop, because yeah, it's definitely different than most loss functions. So yeah, it's gonna require modifying training loop. We're probably gonna have to do like where we normally compute the loss. Where do we normally compute the loss? Where we normally compute the loss, we're going to have to do like probably an else if statement or something, because it's going to require essentially that custom thing where instead of just taking the model output, we reinitialize the model output and the actual values and throwing them into the criterion. Where is that actually? Training loop. Oh yeah. That's the trainer. So yeah, instead of just throwing them into the loss like this, we're probably gonna have to do like if criterion is instance of Gaussian loss and actually import that. So yeah, I'll commit this stuff, and then tomorrow probably We could actually begin to import. So and yeah, in general, I don't like import it. That's why we have the whole dicks. Import Gaussian. Is that like? Oh, it's in custom. We need to change those directories better. I think definitely what Wendy said a while ago was we need to have like a separate file just for loss functions. I think in Python you can do like an instance of. So and then just do, so yeah, in train transformer style, which is here, in the training loop, here we do it. So like, so if is instance, right? So yeah, I'm just laying out what we'll do. Okay, so I'm gonna like end the stream for now, and then we'll come back tomorrow.